Hi everyone, and welcome to today's Physics Daily Booster. This is number 3 in our series. Again, not explicitly listed on the advanced information lists, but that doesn't mean it's not coming up, because it's also not listed in the excluded topics for anyone. What we're going to do then is start looking at pressure. So what we start off with, great example, something we all know, is if we blow up a balloon. So at the point that you're blowing up a balloon, you're increasing the number of air particles inside it. Those particles are obviously moving, they're a gas, and they're going to collide with the surface of the balloon. Every collision creates this small force, and it's those collisions and that small force that is going to be the pressure of the gas, pushing the balloon outwards so it expands. If we consider another scenario where we're adding more air particles to a container that can't expand, then what we see is the pressure is going to increase. Now, obviously, if it can't expand, it's going to increase to a certain point and then the item will explode. Hence why you don't do things like increase the pressure inside things like deodorant cans, for example, because if they explode, it's quite messy. Now, what we find, one of the ways that we can actually increase the pressure is by increasing the temperature. Because when we increase the temperature of a gas, the particles are going to gain kinetic energy, and therefore we have more frequent collisions with the sides of the container, causing that increase in pressure. So do remember that we're looking for the idea of gained kinetic energy and therefore more frequent collisions. Now, as soon as that happens, pressure increases. In terms of how we measure the pressure, we can actually just use a pressure gauge. Now, pressure is measured in the units of pascals, and we do have those little conversions there to things like newtons per meter squared, etc. Don't forget, if you see the little K in front of your typical units, then that means kilo. So there are 1,000 of that individual unit for 1 kilopascal in this case. If we think about temperature decreasing, then pressure will decrease, because what we're doing there is we're actually slowing down our particles, so there are going to be less frequent collisions, so a lower pressure. If we had the ability to cool down that gas to absolute zero, so 0 degrees Kelvin, then it would have a pressure of 0 pascals, because at that point the particles are just not moving. Now, because experimentally getting the gases down to 0 degrees Kelvin, not likely, then we actually do this by extrapolation of a graph. So you've got results from things we can get to quite easily, and then you just extend the line out to get to what it would be. We now need to consider another relationship for our pressure, which is pressure and volume. We have an inversely proportional relationship between pressure and volume. What that means is that if the volume doubles, then the pressure will halve. Please note, if we are seeing words like doubles, halves, etc. in the question, you need to use a similar term in your answer. So if you see volume doubles, pressure will halve. If the volume halves, the pressure would double. So you've got to use that. You can't just say increase or decrease. We need to be more specific here. In terms of the direction of the force, this is sometimes a nice little one marker, sometimes in multiple choice particularly. Then the collisions of our gas particles will create a force at right angles to the surface. So do remember that. In terms of how we can use our pressure in any form of a calculation, pressure times volume in meters cubed is our gas constant. So we can see that occasionally, but not too commonly. Our next consideration is how we can actually increase the internal energy of our gas. And there are 2 ways we could do this. First one, heat it. Second one, do work on it. And I've given you the example of what we mean by do work in the picture on the left there. Using a bike pump means we're doing work on it. Because by applying that force to the pump, we're actually going to have those more frequent collisions with the particles, leading to that transfer of energy. So as a result, there'll be more frequent collisions with the container, and therefore the pressure will increase. The next type of pressure we need to understand is atmospheric pressure. Now, hopefully we all know that Earth is protected by an atmosphere, so basically a layer of gases around the whole planet, and it's going to be up to about 700 kilometers. Those gases are obviously pressing down on the things beneath them, and therefore they exert atmospheric pressure. Depending on how far from the surface you are is going to determine the atmospheric pressure. If we consider one of our simple little examples here that you may have seen is the little collapsing can trick. So when we start off, we've got equal forces in all directions, so the can just stays the same shape. If, however, we remove the air from the can, it collapses down because we've got a greater pressure externally acting in than internally acting out, so the whole thing collapses. If we apply this kind of idea to atmospheric pressure, what we're really doing is, as we move further from the surface, so as we're ascending higher up away from the surface, then we're actually moving through more of those bits of gas. So that means that there's fewer molecules of gas pressing down on us. As a result, atmospheric pressure decreases. So if they ask you what happens to atmospheric pressure as you go further away from the surface, it decreases. The reason for that is there are fewer particles of air pushing down on you. The final type of pressure we need to understand is liquid pressure. All liquids will exert a pressure because they're going to be colliding with each other, the container, etc. Now, liquid pressure is different to gas pressure because it acts in all directions. What we're going to find then is as we go further down in a liquid, then we have a greater pressure. Same kind of idea as with the atmospheric because there are more particles above us pushing down. Second thing to consider here though is about the density of the liquid, because the more dense the liquid, the greater the pressure will be. And that's all down to the fact that the more dense liquid obviously has a greater weight of liquid pressing down on that particular object. So a good example of how you can see this is the old water bottle with different holes at different heights. The one at the bottom is able to project the water further because it's under greater pressure because there's more water molecules above it. Calculation, again we'll find it on our formula sheet. Pressure is the height in meters times the density of the liquid times gravitational field strength. Now gravitational field strength on Earth is going to be 10. Height, do note it is in meters. So if we see height, that also applies to depth, by the way. So height or depth in meters times the density times gravitational field strength, which if we're on Earth will be 10, will give you your pressure. Formula on the formula sheet, you don't have to learn it. The last thing to look at for today then is just this idea of floating and sinking. So if we've got a scenario where something is floating, that's going to happen because upthrust is balancing the weight. So upthrust acting upwards, weight acting down towards the centre of the Earth there. Another calculation we could find here, pressure is force divided by area. And just remember that that could be applied to scenarios where we've got obviously different areas of things in contact. So one of the old favourites was about snowshoes versus kind of a smaller shoe print. Snowshoes have a much larger area, therefore the pressure is less, so you sink less deep in the snow. Whereas if you've got very narrow shoes, the area is smaller, therefore the pressure is greater, you sink further in the snow. If we think about the example of submarines, then it's all about having this little structure that allows us to increase, obviously, the amount of water in those tanks. So that means that by doing so, what we're doing is increasing the mass, and that means that we're then going to be increasing the weight. Because as we increase mass, weight is just mass times our gravitational field strength. So increasing mass increases the weight. That means it would be greater than the upthrust, therefore the item would sink. Final thing to do for today then is head on over and have a go at the quiz, check how you've understood the bits on pressure. Obviously, if there are any areas that you're not 100% certain on, it's worth going over them just in case there are questions, because we know that they're not excluded on any of these papers. So have a look at the videos on the main channel, your revision guides, your notes, anything else that might be of use to you. Don't forget to join us again tomorrow for our next Physics Daily Booster.